All right, ladies and gentlemen, welcome to class. We are continuing our discussion on graphing quadratic functions. And yesterday we introduced the basic pattern of quadratic functions. And does anybody remember something about that pattern yesterday? What do you remember about that pattern we had for y equals x squared? Anyone?
+1, +3, +5.
Okay, Justin just mentioned +1, +3, +5. Very good. And what happens is the pattern, if we have 0 squared, we get 0. And what Justin said was +1, +3, +5. And it creates a pattern. 0 + 1 is 1, 1 + 3 is 4, 4 + 5 is 9. And then because of symmetry, we have the same thing over here on the other side of the axis. So we have 0, 1, 4, 9. And then if we were to graph this basic parent function of precalculus, it would just be, we can go, we have the origin, then we have the 1, add 3, add 5 more, 9. And so that's your basic pattern for graphing. And so you can determine what's going on with a quadratic function by what? If we look at this, well, let me go ahead and mention the pattern that we're going to use is found by taking a times +1, +3, +5, as Justin said. So in this case, what is our value of a?
6?
No.
-1?
Okay, in this case, a is equal to -1. Okay, so if we go ahead and transfer this to this pattern and multiply this by -1, what are we going to get?
-1, -3, and
-5. And so that's going to be our pattern. And so now I'm going to erase this. And do we have a vertex here? What is our vertex for this function here? By the way, this is called, this form right here of a quadratic function, this is called a vertex form. Do you remember, Karina, you remember talking about this last year, the vertex form? Elizabeth, you remember this too? Vertex form, and have 2 honors? A little bit? Okay. Yeah, this is called vertex form because this gives us our vertex. And what is our vertex for this thing here?
-6,
So -6, 5 is our vertex. And so we can start right now by showing what the points are. We go to x, f of x, and the first thing you put here, right in the middle, is the vertex. So we can put -6, 5, right here. So it gives us our starting point. And now we can we go and increase by 1, so -5, -6 + 1, we got -5, -4, -3. On the other side, we decrease by 1, so we're going to put -7, -8, and -9. And now here's where the -1 comes into place. What's 5 minus 1?
4.
4. And what's 4? We're going to have -3, right? What's 4 minus 3? 1. And then finally we have -5, so what's 1 minus 5? -4. So now we can do the same thing over on this other side. So we're gonna put 4, 1, -4. Do you see, Riley? Anybody else? Why this pattern would go ahead and be the same over here? You see why? Because of symmetry, right? Because we have the symmetry. We know one side is the same with the other, so these output values are going to be the same as these output values over here. And then we can also see that we're starting at a maximum of 5, so that kind of informs where we can draw our graph. So I'm just going to make my graph paper down here someplace. And we know we're over to the left of the y-axis. So I'm going to make my y-axis right here like this. So we have x and y. So we can put our vertex here, graph the vertex, we put -6, -5 is our vertex. So -1, 2, 3, 4, 5, 6, and up 5. And then we have the -1, -3, -5. So I can just, instead of going to here, I can just go to the graph, can't I? Go 1 to the right, down 1. Go 1 more to the right, down 3. Go 1 last more to the right, down 5. 1, 2, 3, 4, 5. And then we can't, what happens is this thing right here that I'm sketching in dotted line, what do we call this? The what? The axis, thank you. That was Chloe, right, Chloe? Well, I was Elizabeth. So I was directionally correct. Axis symmetry, yes. And it's going to be x is equal to -6. And then over here we have, because symmetry, this one, and this one. And so now we can sketch this, right? Now I'm not going to sketch this nearly as neatly as Elizabeth does, but see, I drew it kind of pointed, didn't I? At the end, but anyway, that's how you would do that. Does this make any sense in the wide world of? It does? Okay, good. And for those of you who were here yesterday, everybody else, is this sort of helping to review and kind of put things together from yesterday a little bit? Chloe, you okay on this? Good. What about you, Corinne? Is this working out okay? And then I'll have you do one more sort of a independent practice thing here. Let's see, yeah, I'll have you do one of these here. Here, why don't you do this one right here? Can you do this one? Try this one. This one here, A is what? A is equal to 1/2. So keep that in mind. While you're working on that, I'll take attendance.
That's A h minus k squared minus what?
What was your question?
The formula,
Yeah, it's going to be A parentheses
h minus k squared.
x minus h squared plus k.
X minus k
X minus h. X minus h. Yeah.
plus k.
Plus k. Yeah, k is the last thing to go. this one here, what is our pattern going to be?
1/2.
So you say plus 1/2,
Yeah.
and then plus
3/2.
3/2, plus
5/2.
5/2. And it might be easier for you to deal with. You could make this 0.5, 1.5, 2.5 also, right?
Yeah.
That might make it easier for you to deal with. And then, what is our vertex for this thing?
-3, 5, -5.
So, x, g of x, we have -3, and then -5, is that right?
Yeah.
And then we put in the other numbers like -2, -1, 0. And then -4, -5, -6. And then we add plus 1/2. Then we're gonna add plus 3/2. And then we're gonna add plus 5/2. And then, so I'm gonna just go ahead and use a decimal version. Would you mind if I did that? What's -5 plus 1/2?
-4.5.
-4.5. And then if we add 3/2, we get,
-2.
I'm getting -3, right?
Oh.
Is that right?
-1, -3.
And then, yeah, and then the next one's gonna be
It's -1.
-0.5, right, or -1/2. And so now what do we do over here?
Same thing.
Same thing, we just take the same numbers. And so now we can just graph this. And again, like the other one, we're over to the left. So x, y. So we have our vertex, -3, -5, so here's -3 and down. 1, 2, 3, 4, 5, right here. And then we have x equals -3, that's our axis of symmetry. And then we have plus 1/2, plus 3/2, and plus 5/2. So it'll look just like this. Then because of symmetry, we can go like this, this, and this. What are going to be the x-intercepts of this function here? It's going to be -6, a little bit to the left of 6, right?
Yeah.
And this one's going to be just a little greater than 0. And how do we find that? We're going to work on that later. But you would set this equal to 0, and you would solve that way. We're going to do that later, but we're just graphing today, okay? How's that? Are we okay with that? Okay, I'm gonna give you another, we're going to explore another type of function, a quadratic function. And we're going to graph from another type of function, and it is this type of function, which is, what kind of form is this in? What kind of, okay, Elizabeth says slope-intercept. Well,
I don't think that's right.
it's not slope-intercept form. Slope-intercept form is for a linear function, right? Does anybody remember what we call this form here? Starts with S. Standard form, okay? It's standard form, and sometimes you hear it called general form. And so, what's an advantage of this type of equation compared to the vertex form? All we have to do is solve? Well, to me, what's easier about this one is you can see the y-intercept, which is really easy. What's the y-intercept here?
7, -7.
Y-intercept is -7, right? So you can see the y-intercept, but is it really apparent what the vertex is?
No.
No, it's really not. And so what we're going to do is we're still going to be able to graph, because we know A, B, and C, and I'm going to introduce a formula to you. So A is equal to what?
1.
1. B is equal to 2. And C is equal to
-7.
-7. All right, if you look over at the wall,
It's like A squared to...
yeah, so what's happened is there's a little song. Negative B over 2A. Start with negative B over 2A. Graphing parabolas the easy way. Start with negative B over 2A. Okay? Does that make sense? No? Yes? Elizabeth's nodding. So x, our equation for x symmetry, x equals negative b over 2a. And so in this instance, what is negative b going to be?
-2.
-2 over 2a. So what does this simplify to?
-1.
-1. So that gives us our axis of symmetry. So we already know where our axis of symmetry is, and we can actually sketch what it is. I'm going to do that right now. So anyway, I'm sketching our axis of symmetry. I'll come down quite a ways here. Okay, our axis of symmetry is x equals -1, right? So x is equal to -1 as our axis of symmetry. And now we can come and construct a table, can't we? So we have x, f of x, and we know that our axis of symmetry is -1. So what can we do with this -1? What can we do? What can we do with -1? Okay, we can go ahead and plug -1 into this function here. So we'll put f of -1 is equal to -1 squared plus 2 times -1 minus 7. And what is this going to be? 1 minus 2 minus 7. What is that going to be?
-8.
Robert says -8. Do you agree with Robert? Yeah, Justin says yeah. Well, I agree with Robert. Good job, Robert. So we put -8, and now we have our vertex. So now is it pretty easy to graph the rest of the points? Yeah, so you can go, you put 0, 1, and 2 here, and here -2, -3, and -4, and now we can, A is 1, so what is our pattern going to be? Justin, what's our pattern? +1, plus, I'm saying Justin because Justin gave us to us earlier, right? Justin, you did that, didn't you, Justin? Yeah, he did. He did. Good job, Justin. All right, so -8 plus 1. is negative 7. Negative 7 plus 3, negative 4. Negative 4 plus 5, 1. And then we go over here, we put negative 7, negative 4, and 1. And we can graph everything else. So we go 1, 2, 3, 4, 5, 6, 7, 8. So there is our vertex. And then we have plus 1, plus 3, plus 5. So I was just looking off the graph grid. I was just going plus 1, plus 3, plus 5. And I wasn't even looking at the table, was I? Well, you don't know if I was or not. I promise you I wasn't looking at the table. I was doing plus 1, plus 3, plus 5. And now can we graph this? Yes, we can. Oh, look at that. See, that part of the right part of the curve was almost as neat as Elizabeth. Oh, it's hard to do. Anyway, does that seem like a pretty good way to do? Would you rather graph a function here from standard form or from vertex form? What would be easier for you? Vertex form. Part vertex form. I would be too. Now, one thing you can do is you can go ahead and you can convert these to vertex form too. So that's one way to do it. So you can either do this and find, using negative b over 2a, and find the vertex, or you can change it into a vertex form. And there's a technique to do that. It's called completing the square. Have you ever heard of completing the square? Oh, yes. We talked, remember, Elizabeth, us talking about that last year?
I think we did it in this conference, or I did it in there.
And this, yeah,
Yeah.
yeah, this is good. So we're going to do some of that. I want you to, oh, another thing, where does this equation come from? Negative b over 2a. Do you know where that comes from? You know? It comes from something called the quadratic formula. X equals negative b plus or minus
Square root of 4ac, no, 4.
b squared
B squared plus minus, I thought it was
minus
plus
4ac
over 2a.
over 2a. And so where the equation comes from is this part of it right here.
That's the easiest. I can solve that like nobody's business.
So you know how to do that really well?
Yes.
Well, that's really good. That's really good. And there are songs and memory devices for it too. And I'm going to share one that I have.
I think that was the easiest thing I did in algebra 2.
Oh, really? Okay. Well, that's a very helpful thing because we can use it here somewhat. Okay. A negative boy went to a radical party, but because he thought he was square, he missed out on 4 awesome chicks. And the party was over by 2 a.m. So, anyway, I had a pre-calculus student years ago who came up and told the class, Justin. So that's one thing to remember. Then there are songs too. The quadratic formula, the quadratic formula, and it's negative b plus or minus the square root of b squared minus 4ac over 2a. So, and there are all kinds of other songs.
Mr. G, you should go on American Idol.
Really? Okay, I don't know. But see,
Sing
they
your
want
math songs.
the rap songs. They mostly want younger people for those, is what the deal is. That's more photogenic. We'll see. But anyway, that's that one. What I want you to do is take out, is try this one here. Try to do this one. And then after this, we're going to probably go to an exercise set. just as a check, I think for this one, what did you get for your axis of symmetry? X is equal to, okay, Riley is making this gesture to the camera. Riley says 3, X equals 3. Is Riley right? Riley is right. Good job, Riley. So just as a check. Now, tomorrow's going to be a bit of an interesting day in that the seniors are set to be taking your SAT tomorrow, is that right? And probably it's going to affect this very class period.
Yeah, we're not gonna be done until B-lunch.
Yeah, you're not gonna, so probably for those of you, the juniors who are here, we might do factoring practice or something like that. I'm not sure what the rest of us will do tomorrow. So that's just what's happening tomorrow. You guys, are you good on your SAT strategies and all that? You're not? Well, I'll talk, as soon as the camera's off, I'm going to talk about that a little bit. Okay, we have x equals negative 6 over 2 times 1, which simplifies to negative 3, because a is equal to 1, b is equal to negative 6. What? That's going to be negative 6, right? Yeah. And c is equal to negative 6. So now we have 3, right? Negative, so x is equal to 3. Is that right now? Did I get it right finally? So we can go ahead and already, do we have a y-intercept? Yes, negative 6. So we know negative 6 is going to be part of the deal here. We know that. Okay, and I think what I want to do for this one is I want to give myself more room on the upside. So I'm going to move this point here too. Whoops. 3. Does that look better? Is that almost looking okay? Yeah, that was good. Okay. So now, for a table, we can go x, f of x, and we can put 3 over here. And what do we get when we put 3 in here? What's f of 3? We get 3 squared minus 6 times 3 minus 6. So that's going to be 9 minus 18, which is what? Negative 9. Negative 9 minus 6 is negative 15. Is that right? And then we can put 4, 5, 6. And do we have a equal to 1? Yes. Plus 1, plus 3, and plus 5. And so we have negative 15 plus 1, is that negative 14? And this is going to be negative 11, and then finally negative 6. And then down here we would put negative 14, negative 11, negative 6, and of course we have 2, 1, 0. And so here's our axis symmetry. X is equal to 3. And then we would go down 3, negative 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right here. Then we can go plus 1, plus 3, plus 5. That matches over there. So that's it. Okay? Everybody get that pretty well? Okay, Elizabeth, thumbs up. Okay, good. What I want to do now is go to our exercise sheet, and we'll just kind of get started on this today. I do want to talk a little bit about the SAT before we exit the classroom. So we have this one right here. And let me know if you need graph paper too. Does anybody need extra graph paper on this one?
Yeah, I need another one.
Because the printing of the graph didn't come out too well. I gave Elizabeth two. I expect her to do extra work today or something. Okay. So, do you see how the exercise we've gone over the past couple of days will really help you with this? Can you see why I wanted to do the exercises we did before this, given turning loose with this thing here? Yeah. So, what is our vertex here? Vertex, I got 3, negative 2. And so, and it says, describe how to transform the graph into the function. So what do you have to do? This is what? What do we do to transform from here to here? What do we do?
Square.
Okay, down to, so we would say translate down 2 units, right? And also, what else?
To the right.
Translate 3 to the right. Three units. That would be units, right? Units to the right. And so now we can go ahead and use our x, g of x. I'll put f of x. X, g of x. So we have our vertex here, 3, negative 2, and then we put here 4, 5, 6, and over here we put 2, 1, 0. And do we have a plus 1, plus 3, plus 5 going on here? What is a equal to? 1. That's plus 1, plus 3, plus 5. So add 1, get -1. -1 plus 3 is 2. 2 plus 5 is 7. We go over here, -1, 2, 7. And so now we have a something like this. Yeah. Just trying to make sure we have enough room. That'll be enough room. So we have x equals 3. And then we have our vertex is 3, -2. And then we can go plus 1, plus 3, 1, 2. That's plus 3 there, right? Yeah, I'm just counting a little bit. Then plus 5, 1, 2, 3, 4, 5. Then this. Then this. And finally, this right here. 0, 7. So we have this. Okay, that's it. What I want you to do is go ahead and work on number 20. And we'll just leave it to there today, okay? Just work as much as you can, then we'll finish and work on the back side of these exercises tomorrow. Well, actually, probably not tomorrow, Thursday. For reasons we talked about earlier.